So last day we have ended our discussion on this operator precedence parser. So if you look into this particular tree on various parsers, what we have seen that we have completed the recursive descent parser, LL1 parser. That means the top some of the top down parser is done, and we started the bottom up parser. This part we have done. So what is left? This LR parser. So one by one we will go through these all different types of LR parser. That means the topic for today is LR parser. Now this LR parser actually already it's defined over there, it's categorized over there. Still I'm writing it again that LR parser is categorized in mainly four ways. The first one we call LR0, second one we call SLR1, and some people also say LR1. Third one we will call LALR1, and last one is CLR1. Now you see among these all are LR parser, and this LR0 parser is actually the basic version of LR parser, and all these are modified version. One by one they has been modified. And remember one thing, that this LR0 parser is, I mean, since this is actually basic version of LR parser, that's why this is least powerful. And this SLR1 parser is called simple LR actually. That's why it named SLR. And this LALR is called look ahead LR. And this is what we call canonical LR. So obviously some terms has been arised that you don't know. For example, canonical, and many more terms will arise in future. So don't be confused, that one by one this will be clear to you if you carefully watch this particular lecture. Anyway, so since this, I mean, we started with least powerful, and remember one thing: this canonical collection, canonical LR actually is what you can say the most powerful parser. Okay. Now, one more thing is there. You can categorize it more. Not categorize it. You can actually combine these four parsers and actually categorize in two way. In a sense that these two and these two can be combined. I mean, in a way. And the reason of this, that these what we call, they use canonical collection of LR0 item. Just I'm informing you, and one by one the term will be cleared. Okay. And this what we use canonical collection of LR1 item. Okay, so definitely some terms is not may not be clear. For example, what is item, you don't know. What does canonical collection mean, you don't know. So this will be clear one by one. But remember one thing, that is a common thing in between all these parsers, that is the common is that the algorithm. All these LR parsers use same algorithm. So what is the difference? Difference is that designing some table, as you have seen in case of LL1 parser, or maybe in case of operator precedence parser, there is a table and the algorithm use table in some way. In the same way, in case of LR parser also, each and every parser utilize a table. So the parsers actually difference with respect to the tables. The algorithm remains same. So that means you can say, just like you can imagine something like we have a stack over here, just like in previous case we have seen that this is our stack, okay, and there is a input string which is presented in some tape. This is your input string, and which will embed with a dollar, as we all know. So there is a parsing algorithm. So here we have this LR parsing algorithm. Okay, I'm not exactly writing whether it is LR0 or SLR1 because the parsing algorithm is common for all the different parsers. The parsing algorithm take this input, this is your input string, and there is what you can say a parsing table. And it takes data from this parsing table, and depends on that obviously it uses the stack. This is our memory in form of stack, and using this stack and parsing table ultimately it check whether the string is correct or not and syntactically correct or not. Okay, now you see this particular diagram is almost same as already we have seen this type of diagram in previous parser. So I don't think there is something new, with respect to the architecture there is something new over here. But what is the difference? The difference is that there is two function. There is two function, as you have seen in case of LL1 parser, there is a function first and follow. Here you have to consider two function. So we will consider two function here, two just like first and follow. Okay, but don't think that they will be, the function will work same as first and follow. Okay, the number one we call closure, and number two we call go to. Okay, so what the mean these two, one by one it will be clear. So how this works actually, how what does closure mean and what does go to means, let's one by one we will understand. So let's start with a very simple example. Okay, so suppose we have a grammar something like this: S to A to A to small a capital A, or it can be A to small a. I have written separately here just to so that you can understand that there are actually three different production rules present here, right? Now using this particular grammar, maybe you can generate a different type of strings combining some combination of A's and B's. Now you see, um, ultimately what type of parser we are going to design? You see, we are going to design bottom up parser. So the technique will be something like what? The technique will be, you have the string, and from the string the parse tree will be generated from the string till the start symbol. So it's just in a opposite, just in a opposite way, right? So that mean, if we have some string over here, for example say W is a string, and there is some symbols present here. Okay, generating this string. And you see, suppose that, you know, in this particular string, these two symbol, some symbol I'm just written in X, these three symbols is forming an A. Okay, somehow, okay, obviously somehow. Now, as a parser designer, or maybe if you think that you are doing the parsing, you will see that, you see, I have this production rule S to AA, and ultimately if you start from this string and your intention is to reach up to S over here, and what you have seen, that you have seen that, okay, you have seen this first A you have seen, but the path from some another part of the string to the second A is not still created, and that is why you cannot apply this particular production rule to reduce from capital A to small capital S. Like, after doing this, if somehow if you get some more symbols here which generates the second A again, then you can combine them to form this S. But until you have seen this second A, you cannot use this particular production rule to generate the start symbol. And here the point comes, that means somehow you have to understand, you have to somehow note down that which particular, in a particular production rule, for example maybe the first one or second one, which particular symbol or set of symbols you have already seen and which is still left to see, to get, understand. So that means, and here the definition of item come. So what the item mean? So here the definition of item come. What is an item? What is an item? You know, over here already you have seen this particular term, item. Item. So what item means? Item means, you can say that any production having a dot, dot means symbolically dot. Okay. In the RHS, is called an item. Now you see, I have not mentioned where the dot will be. That means there is a possibility that, for example, there is a possibility that it can be something like S. For example, I'm just taking one production. For the other production, rule remains same. So the dot can be something like this. Here the dot, and then this A and this A. Right? Even it can be also like something like this. A, then dot, then this A. Even it can be something like this. A, and then its dot. And obviously for these three cases we have separate meaning. What does it mean? It means that we have not seen, actually we have seen nothing in the RHS. What does it mean? For example, over here, as I told you that, okay, somehow that this path has been, I mean, you have somehow created from the some set of strings to capital A, first capital A, but the second capital A path is not been created. But you see, just assume that even the first A is not created, path is not created. What does it mean? It means that the first A also not seen. And just forget about the second A. Even the first A is also not seen. So it is the some situation something like this. Now naturally, I hope now you can imagine this one that we have seen the first A, right? But not the second A. Similarly, what does it mean? This means that basically everything of the RHS has been seen. That's why dot came at the end, because after dot there is nothing remain to visit. That means here you can say that everything is seen. Now in other word, this particular item, this S to AA dot, is also called final item, because you have seen everything. So you can easily make the path from, you can easily actually reduce this capital A to capital S. Why I am saying reduce? Because you will start journey from this string, and actually you have to reduce this string to capital S, that is a start symbol. So actually we have to find out in which way we will reduce this, and during reduction we have to understand what are the production rules that we have to use one by one, and which symbols we have to consume for that. That is actually the goal for designing this type of parser, right? So this is all about, I hope you can understand that, all about the what we call item. And now we have to understand how we can design the LR parsing table. Especially you can say we will start with LR0 parser. So definitely we have to understand how we can build up the LR0 parsing table.